Hey, hello and hi. We are talking today about angles of polygons, and this time we are talking about exterior angles as the new information. So if we look at this picture, you guys can see that this is a pentagon. It's got 5 sides, but you'll also notice that every one of the sides is extended beyond the vertex. So the interior angles are the ones that we've been talking about, the ones that are inside the pentagon, and they would be interior angles. Angle 6, angle 7, angle 8, angle 9, and angle 10. But then we've got the exterior angles, and you'll notice they go around like a clock. So this one sticks out, and then we continue, and this one sticks out, and then we continue. They all stick out in the same direction. The exterior angles are the ones that are on the outside when you extend each one of the sides. So the exterior angles in this case would be angles 1, angle 2, angle 3, angle 4, and angle 5. The measures of interior and exterior angles have certain relationships. So interior angles, we had a formula for yesterday or the previous day, S equals 180 times n minus 2. That was specific for interior angles. So let's look at the exterior angles. Measures for interior and exterior angles are shown below. Each pair of interior and exterior angles has a sum of blank. So if we are going to look at interior on a triangle, we've got 60, 30, and 90. If we add 60, 30, and 90, the interior angles have a sum of 180 degrees. Now, what about exterior, the ones on the outside? So this one is 120 degrees, this one is 150 degrees, and this one is 90 degrees. The sum for exterior and interior angles. So if I put this interior angle together with the exterior angle that's next to it, the 60 and the 120 adds up to 180. If I put this 150 together with the 30 next to it, they add up to 180. And if I put this 90 with the 90 next to it, it adds up to 180. So each pair, if you add the interior angle and the exterior angle, they add up to 180 degrees. The interior, because this is a triangle, happens to add up to 180. The exterior, though, it says find the sum of the measures of the exterior angles for the triangle. If I added 150 and 90 and 120, they add up to 360 degrees. Now, what if I do the same for the pentagon? So the exterior angles, 102, 81, 63, 90, and 24, if I add those, 102, 24, 90, 63, and 81, they also have a sum of 360 degrees. So if we were to draw a rectangle, find and label the measures of the interior and exterior angles. All right, so if I pull this up just a little bit, and let's say I draw a rectangle, interior angles would be 90, 90, 90, and 90. The interior would be 360 degrees. Now the exterior, if I follow each line and extend it, then all of the exterior angles, here's an exterior, here's an exterior, here's an exterior, and here's an exterior, they are 90, 90, 90, 90. The exterior angles also add up to 360 degrees. So what can we say? Even if the shape changes the number of sides, the exterior angles are adding up to 360 degrees. The sum of the exterior angles of any polygon is always equal to 360 degrees. That is specific for the exterior angles. Find the measure of angle 4 in the triangle and show your work algebraically. So we have 92 degrees exterior angle, 123 degrees exterior angle, and angle 4. So we're going to do the 92 that we know, plus the 123 that we know, plus the missing measure of angle 4, and they have to add up to 360 degrees. So the two that we already have, they're taking up 215 degrees plus x equals 360. And if I take away 215 from both sides, x, the missing measure of angle 4, would be 145 degrees. So the measure of angle 4, and that little lowercase m means measure of angle 4, equals 145 degrees. Now, how do we find the missing interior angles? Remember we said that a pair of interior and exterior that are next to each other have to add up 92 plus the missing angle 1, have to add up to 180 degrees. So the missing measure of angle 1 would be 88 degrees. Angle 2, if I put it together with the adjacent exterior angle, I would say that 123 plus the missing angle has to add up to 180. That makes the missing 57 degrees. And last, angle 3, we just found that angle 4 was 145 degrees. So 145 plus that missing angle 3 would have to add up to 180, making angle 3 35 degrees. Now, you also could have said if angle 1 is 88 degrees and angle 2 is 57 degrees, the 3 interior angles have to add up to 180. That would have been another option for finding the third. If a pentagon is regular, the measure of all exterior angles is blank. Exterior angles. All exterior angles have a sum, no matter what, of 360 degrees. I don't care if it's regular. I don't care if it's irregular. If it is a polygon, the exterior angles add up to 360 degrees. Each exterior angle of a regular polygon is 45. How many sides does the polygon have? So we're saying 45 times the number of sides has to be 360 degrees. Now, why is that? Because the number of sides is the same as the number of exterior angles. If each one's 45, how many 45s does it take to make all 360? If I divide both sides by 45, n equals 8. So we could say it has n angles. We could say it has n sides. It is an octagon. And if we wanted to draw it, we would see that there would be 8 exterior angles. We would add 45 8 times, or 45 times 8, which is 360. Each interior angle of a regular polygon is 144 degrees. How many sides does the polygon have? Show your work. So the interior angles are 144. So interior angles, and it is a regular polygon, we would have to say each interior angle of a regular polygon is 144. So let's just picture this. Let's say this is your interior, this is your interior 144. What's your exterior, right? They have to add up to 180. So here's my interior 144, that's very smudgy, and here's my exterior. So 144 plus some missing exterior has to add up to 180. The missing angle, the exterior angle, would have to be 36 degrees. And you're like, well, why do I want that? Well, if each exterior angle is 36, 36 times how many angles would it take to make 360? If I divide both by 36, n equals 10. There would be 10 36-degree exterior angles, and it would have 10 angles, so it would have 10 sides, so it would be a decagon. A regular polygon has 12 sides. Find the measures of each interior and exterior angle. All right, so let's start with the fact that it's got 12 sides, and we know that exterior angles always add up to 360. So there are 12, and each one is how big, 12 times what size, equals 360. Divide both sides by 12, and n is going to be 30 degrees. The exterior angles are 30 degrees each. So each exterior angle is 30 degrees. If the exterior angle is 30 degrees, right, here's my exterior angle that's orange, how many degrees then is each of the interior angles? Now, it said it's regular, so they're all going to be the same. So if it's 180 has to equal 30 plus this missing interior angle, if I take away 30, each interior angle is 150 degrees. Now, another option, if you knew that it had 12 sides, you could use the formula from the previous lesson. The sum of the angles is equal to 180 times n minus 2. You could do 180 times 10. It would have 1,800 degrees, and then you would divide it by 12. So there is another way to do it, but exterior angles, if you can work with exterior angles, they're a whole lot easier. The pair that are next to each other always adds up to 180. All the exteriors add up to 360. Two short and sweet rules. Last, find the value of x and y. So we're looking for the missing exterior angles. Okay, so we've got to take this one step at a time. This is kind of like, what's the word I'm looking for? It's like a puzzle. So if this one is 90 degrees, we know that the one on the outside has to add up to 180. So this interior one plus this exterior one that it's next to has to add up to 180. So it would be 90 plus what missing angle equals 180. Subtract 90 from both sides. The missing exterior angle there is 90 degrees. So that's not too terrible. The other thing we know is that we have this angle that's y degrees, and you'll notice that there's one arc. Well, there's one arc over here too, so this missing angle is also y degrees. So all of the exterior angles have to add up to 360, right? So this is the piece of the puzzle that you would need to put together. I have a 90-degree angle, which I just found, plus y, plus 75, plus 67, plus another missing y. They all have to add up to 360. Those are your exterior angles. If I add up the ones I know, the 90, the 75, and the 67, they add up to 232, plus y and y would be 2y equals 360. I would take away the 232 from both sides, and I would have 2y equals 128. Divide by 2, divided by 2. The missing y has to be 64 degrees. So the two missing angles, angle x was 90 degrees, and missing angle y, 64. Oops, sorry, you couldn't see that last little bit there. The 2y equals 128. So first I had to subtract on both sides, and then I had to divide on both sides to get that 64 was the missing angle. So if I put in 64 here, and I put in 64 here, my 5 exterior angles add up to 360.